When you're looking for an air-filled utility, a water-saturated soil can be very helpful. Keep in mind that the only change in this scenario is that we change dry sand to wet sand. Let's talk about this for a minute. So what's the difference between dry soil and wet soil? This is not a trick question, it's water. Water has a very high dielectric constant, or dielectric permittivity, 80, much higher than dry sand or almost any dry material like soil. When you replace the air in the pores between the grains, which has a very low K of 1, with water, which has a K of 80, even though the pore space is a small percentage of the total volume, it increases the K for the soil. In fact, the presence of water in a soil has the largest effect on the K value of that soil. Notice the range of values. Dry sand is 5. Wet sand is 25. If you go to a swampy mixture like quicksand, you can even get K values that are more than 50. Simply put, the more pore space with water in it, the higher the K value for that soil. And that's a great situation when you're looking for air-filled non-metallic pipes. Let's talk about the opposite situation, a water-filled non-metallic pipe. Not surprising, it's the exact opposite. There is more contrast between dry sand with a K of 5 and water, the water in the pipe with a K of 80, than there is between a wet sand with a K of 25 and the water in the pipe with a K of 80. So here are the numbers. 60% reflectivity in the dry sand situation, 28% reflectivity in the wet sand situation. It is going to be easier to find a water-filled non-metallic pipe in a dry soil than it will be in a wet soil. Again, we're found a situation when you want your soil to be water saturated. That is, when looking for a gas-filled non-metallic pipe. Here is everything we just talked about on one slide. In terms of reflectivity, metal objects are always the best. Next is gas-filled pipes in wet soil. Then comes water-filled pipes in dry soil. The hardest objects to find, water-filled pipes in a wet soil and gas-filled pipes in a dry soil. The reason? Less contrast, so less reflectivity. Here's an example of what can happen. The contrast with the utility was high enough that even though the GPR signal was very weak at depth, a high percentage reflected from the concrete asbestos pipe, making it just barely detectable with the GPR. And this is a real object. They ended up digging it up after we found it. What I'd like you to understand from this whole discussion is that when you look at a GPR line, you should be thinking that it's an image showing the contrasts between layers and objects. Some are large contrasts that produce strong reflections, like these ones, while others are more subtle contrasts that produce weaker reflections. If you look at this image from a contrast perspective, there are strong hyperbolas and there are weak hyperbolas. Here's a strong hyperbola that's weaker even though it's deeper. Here's a weaker hyperbola that's shallower than this deeper one. There's information in these observations that will help you interpret your GPR data better. When we zoom in to this area, we can see a number of weak hyperbolas. I want to emphasize that those are real objects in the subsurface. I've heard people say phantom hyperbolas. I don't know what those are, but I don't believe that phantom hyperbolas exist. A hyperbola, whether it's strong or weak, is a reflection from an object. The strength of the hyperbola is due to the contrast between that object and the surrounding soil, as we've been discussing.